Hello everyone, my name is Ong Kambai and my teammate Nanny Ichi. We are presenting about our Cycontrol project, which is a unified mobility solution for the Ho Chi Minh City. So first, let me explain about our project. The Saigon Flow ran three services: e-bike, shuttle bus, and the Flow Pass. But they share the zero data, and the same customer may show up as two or three different users across the systems. So we call this as the ghost commuter problems. The loyalty data of the business is lost, and also we can't see our own customers. This is our current state, the access diagram. So as you can see, three completely isolated databases without any connection whatsoever. So our solution for this is a unified cloud platform that links all our three services, maybe using a phone numbers as our matching key or create one master user ID per customer. So one identity for everywhere. This is how our unified platform will work. Every transition, e-bike ride, and the shuttle booking, the flow-based payment will flow into a single share system tied to that one user ID. So this is before and after we solve this problems. So before that, fragment identities, no loyalty, the reacted management. But after we solve with our implementation, consistent identity, cross-service reward, and predicted insights. So this table is the entire value of the platforms. So this is the risks and the responsibility AI. So we identify four key risks: the algorithm bias, data privacy, over reliance on AI, and API downtime. Each has the concrete mitigations. So we will solve them with fairness audits, end-to-end encryptions, human oversight, fallback catchings, and also with the also in here what we have to care about is AI is for decision support only. The decision maker or the user or the managers themselves. For the business value of our business, our project is three outcome: revenue growth through cross-service upsellings, customer retention through predicted churn alerts, and also the operational efficiency. The tower product is 60% of peak hour revenue with AI fleet optimization. So this is our timeline to implement the projects. This can just show the from the writing proposal, presenting proposal to the final presentations, and also including the analysis and AI deployments. So this is for our part one. So let's go to part two. In part two, we build a accurate prototype with time screen commuter super ads and a sys screen fleet manager dashboard, and also with the fleet Flowbot AI and the live balance scoreboard for the managers. So in the commuter ads, once the user open the app, he will see a live map with a test-based model switching across our services. This UI UX is like the Grab, like famous uh, taxi service. So user don't have to worry about confusing the systems. And also this is after the user choose destination, he can book across the services. And also in here, as you can see, Flowbot lets user ask what is the cheapest way from the current destination to his destination. He can choose multimodal options, and also in here, Saigon Flow, only one wallet for all our services. This is the Fleet Manager dashboard. This dashboard shows the four critical KPIs in under like 3 seconds, and also this is the live heat maps for the manager. The maintenance screen also we can here see the maintenance tabs, business analysis, and balance scoreboard tabs. So this in with this heat map, the manager can control according to the traffic and peak hour times. So this is the maintenance for the e-bike, and you can see all the fleet data of the e-bike in here and manage according to the flags and the reasons. This is the balance scoreboard in here. There is full perspective, the financial, customer, business process, and lending matrices, all in one view. But this is just the general view. You can click on the each categories and go to see the details of under each categories. So this is some of the when you click, like I said, when you click on each category, you can see the more data and you can decide on these detailed metrics. So this is a summary for our part 2 presentation. Now let's go to the part 3. In part 3, we haven't coded the predicted model yet, but we already think about what we will build and also what matrix variable we will use for the AI. So there's two predicted model. Model one use decision tree to flag the e-bike at risk of battery failure. For input will be in here: battery percentage, day since maintenance, vehicle dies, and trade count. So in here, from that variable, he will output as the risk score, high, median, and low uh, according to our score, and also depending on that, the fleet manager see why a vehicle is flagged and also must confirm before any patch. So uh, this is how we implement for this model, and this is the real data of from our data sets. And also this is the return on investment for the model one. So applying to our real data, 220 critical vehicles and over 88 million Vietnam down are at risk. So at 60% prevention rate, the model can protect 53.3 million Vietnam down per maintenance cycle. So this is for the model 2 to predict the user chance. So this use logistic regression to predict the user chance 40 days before it happens using the loyalty points, trip frequency, age, and preferred modes. So high risk user automatically receives a free Pro Pass credits. So currently 323 users already have CHAM. So 44 million Vietnam are already lost, and retaining just 30% of the future average user will recover 40.1 million down by cycle. This is our balance go about. So set a clear targets, revenue up to 41% to 400 million Vietnam down, chance below 10%, at risk behavior below 5%. And we also expect our AI accuracy will be above 80%. So total addressable savings will be over 67 million Vietnam down per maintenance cycle. So this is the summary of our presentation. So we solved the goods commuter problems, and also the fleet optimized churn predict, and we will save like 53.3 million down estimated by cycles, and we can recover 40.1 million down per maintenance cycle. So this is all for our presentation. Thank you, everyone.